Hello guys, welcome to the channel. Today I'm going to look at Hdfs. Last time I looked at the loan eligibility using support vector machine algorithm. So today I'm going to look at Hdfs. So guys, let's subscribe to the channel. So what is Hdfs? Hdfs is the Hadoop distributed file system. So in this context, you learn Hdfs, learn the Hdfs and application scenarios, Hdfs related concepts, Hdfs architecture, then the key features. So let's define some keywords we should consider when talking about Hdfs. A file system is a method of storing and organizing computer data. It makes it easy to access and search for computer data. Another term is file name. In the file names are used to find the storage location. Another term is the metadata. Metadata is the data storing file properties such as file name, file length, user group to which the file belongs, and the file storage location. Another term is a block. A block is a minimum unit for storing files. That's a minimum unit for storing files. So guys, let's define what Hadoop is. Hadoop distributed file system, the HDFS itself, is a distributed file system designed to run on a commodity hardware. HDFS has high fault tolerance capability and is deployed on cost-effective hardware. So guys, you should know that the Hadoop distributed file system is just a file distributed system that is designed to run on a commodity hardware. Then Hdfs is a part of the Apache Hadoop core project. So application scenario, we have the website data, storage and social media data. We have the e-police, we have the meteorological data, the sensor data. The sensor data, this one, then the meteorological data, this one, then guys, an important information to note that the HDFS architecture consists of three parts, that is the name node, the data node, and the client. A name node stores and generates the metadata of the file system. It runs one instance. A data node stores the actual data and reports data blocks managed to it, the name node. Multiple instances can run on a data node. A client supports HDFS access by service. It obtains data from the name node and data node and sends the data to service. Multiple instances can run together with services. Let's look at the basics architecture of the HDFS. We said that the HDFS has three parts, that is the three parts, that is the name node, the client, and the data node. So we have the client, name node, the data nodes. So, and we say that the name node used to store the metadata of the file, and the client is used to access services. And we say that the name node run on one instance while the client run on multiple instances. So guys, we can see here that we have some data nodes which are they are in blocks. So there is what we call replication. This where the data node, the blocks, the advantage of blocks, where it brings about the backup, because there is replication of data. So let's look at what is a block. The block default size of a HDFS is 128 MB. A file is divided into multiple blocks. which are used as a storage unit. The block size is much larger than of a common file system, minimizing the addressing overhead. So the abstract block concept brings the following obvious benefits. We say that it supports large-scale file storage, simplifying system design, applicable to data backup. Those are three benefits of block. Support large-scale file storage, simplifying system design, applicable to data backup. Let's look at the namespace. The name node manages the namespace of a distributed file system and stores two core data structures, that is the fs image and the edit log. Fs image is used to maintain the metadata of the file system tree and all files and folders in the file tree. The edit log records all operations on the file, such as creating, deleting, renaming the files. So this is the diagram. We have the namespace. This is the namespace, and then the name node. We have the fs image and the edit log. We say that the edit log records all operations on files such as creation, deletion, and renaming. So after that, let's go and look at more deeper content on the data node. Say that data node are working nodes that stores and read data in Hdfs. Data node stores and retrieve data based on scheduling of clients or name nodes, and periodically sends the list of stored blocks to name nodes. And data nodes on each data node is stored on a local Linux file system of the node. So let's know what the client is. The client is the mostly common used method for users to operate Hdfs. Hdfs provides a client during deployment. The Hdfs client is a library that contains Hdfs file system interfaces that hide most of the complexity of Hdfs implementation. Hdfs also provides Java APIs as client programming interface for application to access the file system. Hdfs namespace. The Hdfs namespace contains directories, files, and blocks. Hdfs uses the traditional hierarchical file system. Therefore, users can create, delete directories and files, move files between the directories, and rename files in the same way as using common file system. The name node maintains the file system namespace. Any changes to the file system namespace or its properties are recorded by the name node. Let's look at the communication protocols. Hdfs is a distributed file system deployed on a cluster. Therefore, a large amount of data needs to be transmitted over the network. All Hdfs communication protocols are based on the TCP/IP protocol. The client initiates a TCP connection to the name node through a configurable port and uses the client protocol to interact with the name node. The name node and the data node interact with each other by using the data node protocol. Here we should know about the TCP/IP protocol, the data node protocol, and the RPC. So we say that the old Hdfs communication protocols are based on the TCP/IP protocol, whereby the client initiates a TCP connection to the name node through a configurable port and uses the client protocol to interact with the name node. Then the name node and the data node interact with each other using the data node protocol. And then the interaction between the client and the data node is implemented through the RPC, that's the remote procedure call. In design, the name node does not initiate RPC request but responds to the RPC request from the client and the data node. So we have the TCP/IP protocol, we have the data node protocol, and then we have the RPC. So thanks guys for listening for this video. Hope you enjoyed. Continue subscribing. Thank you.